Hey folks, welcome to my channel number 10. There we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable. So the function that's been given to us, which is f of x, and I'm going to call this f of x here and in all the other problems that we're going to solve in the upcoming videos. F of x equals x minus 3 sine x, right? So this is a function f of x which is of the type u plus v, right? And where u and v are again differentiable functions which are dependent on the independent variable x, right? So my u of x, and I'm going to call this like this, my u of x equals x, and my v of x equals minus of 3 sine x, right? So here we have our f of x equals u plus v, right? And we know we have been asked to find d by dx of f of x. And if d by dx of f of x, you're going to call it f dashed, what is my f dashed in terms of u and v, right? F dashed in terms of u and v is nothing but u dashed plus v dashed, right? So my u becomes u dashed and my v becomes v dashed, right? So the derivative of the function is the derivative of the function x and the derivative of the function minus 3 sine x, right? So before we directly get to solving the u dashed and v dashed, let's solve some of these basic functions using first principles, right? And then as we progress, let's apply some of these derivatives, what we learn from first principles, into solving those problems, right? So the first few problems in this video and in a few of the upcoming videos, I'm going to be using first principles to solve these problems and also apply the sum rule or the product rule or the quotient rule depending upon the problem to find the final answer, right? So I'm going to start off with my u, right? My u of x is x, right? And so what is my u dashed? So let us write our u dashed of x, right? So my u dashed of x is nothing but limit h tending to 0, and I have my f dash. You don't have to worry about the left hand and the right hand derivative in any of these functions because the basic assumption is the functions that have been given to us are differentiable functions, right? Unless we've been told to examine differentiability, when we've been asked to find the derivative of a function, we can directly assume that these functions are differentiable, and if they are not, we'll have to examine why they are not, right? So let's we don't have to really worry about the right hand or the left hand derivative. We can pick up any one of them, and the one that's usually picked up is the right hand derivative, and I will stick on to that. So my u dash is equal to u of x plus h minus u of x divided by h, right? And what is my u of x plus h? My u of x plus h is nothing but my x replaced by x plus h in u of x, right? So let me write that out. My u of x is x. So what is my u of x plus h is x plus h minus my u of x is x, which I write it and then I have a h in the bottom. My x and x will get cancelled out here. So I am left with a h by h, right? So the answer for u dashed is 1, right? Now let's move to v dashed, and our v dashed is minus 3 times sine of x, right? Now sine x is a basic trigonometric function. So the way I'm going to solve for v dashed from first principles is I'm going to solve for sine x first, right? And then we will move to minus 3 sine x, because minus 3 is a constant and sine x is a basic trigonometric function which whose derivative we will be using in solving many of the problems in the upcoming videos. So I'm going to show you solving sine of x and its derivative, and then we will jump to minus 3 sine of x, right? So let's do that. So what is my, so I will not call it v dashed, so let me call it g dashed, right? And let me call this g of x minus g of x plus h minus g of x divided by h, right? So my g of x plus h, and I'm going to write this out here, right? My g of x equals sine x, okay? And then what is my g of x plus h? My g of x plus h is sine of x plus h. And what is my g of x is sine of x, right? Divided by h. And remember, folks, I still have my limits. My limit is h tending to 0. What is my sine of x plus h, right? My sine of x plus h is nothing but sine x cos h plus cos x sine h. So now I know as h tends to 0, I'm going to use my pen to highlight a few expressions. So I'm going to combine sine x cos h and minus sine x, right? And then we can rewrite this expression as below. 0, and I'm going to combine sine x cos h and minus sine x, which means I can pull out my sine x, which is a common factor, and then I have my cos h minus 1 divided by h, right? Cos h minus 1 divided by h. Right? I have my second part of the expression, which is, again, I can pull out the expression which is independent of h. Remember, folks, independent of h. And my h tending to 0 sine h by h, right? And we know what is this. What is my limit h tending to 0 sine h by h? It is nothing but 1. And similarly, I can also pull out my sine x here, which is independent of h, and I can bring it outside the limits. So I'm left to solve for this part of the whole expression, right? And let's move to the next line. So what is my cos h minus 1? My cos 2a is 1 minus 2 sine square a, right? So what is my cos h? My cos h is nothing but sin x, limit h tending to 0. My cos h is 1 minus 2 sine square h by 2. This is 1 minus 2 sine square h by 2, minus 1, and then I can divide this by h, right? So my 1 and 1 will get cancelled, and I'm left with minus 2 sine square h by 2, right? The answer for this part of the expression is cos x into limit h tending to 0, sine h by h becomes cos x, right? Because sine h by h is 1, and then you have 1 into cos x. So we have solved for part 2. Now part 1 is still pending, right? So let's move to the next line. And I have this expression as sine x into limit h tending to 0. My 1 and 1 gets cancelled out in the original expression, and I'm going to do a quick simplification out here. I'm going to use my pen to show it to you. I'm going to bring my 2, this 2, right? I'm going to bring it down, right? This 2 out here, I'm just moving it to the denominator. So I have a minus of sine square h by 2 because my 1 is gone now, right? And then I have a h by 2 in the bottom, right? Bottom, right? Now I know that my sine h by h, limit h tending to 0, is 1, right? So what is my sine square h by 2 divided by h by 2, right? Don't you think we can do some simplification using the same formula what we have for sine x for limits? I'm going to multiply and divide by a h, right? And I'm left with, and then what I'm going to do, I'm still going to multiply and divide by a 2, right? And let me bracket this so that it becomes a lot more easier for us to visualize. This expression, which I'm going to highlight it in, say, green, is now represented as sine square h by 2 divided by h square by 4, right? And this can be written like this, right? Sine of h by 2 divided by h by 2 whole square, right? The whole square, right? So it still does not change the expression. And now I know that I have more or less solved the problem here because my sine h by 2 by h by 2, as h tends to 0, because my h by 2 will also tend to 0. So this entire expression becomes 1, right? And then I'm left with a h out here, h being infinitesimal. My limit for this entire expression will become 0, right? And I'm still left with my cos x, right? Let's do that in the next step, right? So limit h tending to 0 of this expression will tend to become h into 1, right? Into minus half, which is minus zero point 0.5, right? So the expression which is highlighted in green is what is becoming 1. And I have my cos x, right? So there we have my h is 0. So my final answer is 0 plus cos x, which is equal to cos x, right? So the dy dx of sine x is nothing but cos x. So I'm going back. And so my g of x, which is sine x, my v of x is minus 3 times sine x, right? So the way to remember this is if g of x equals, so my d by dx of g of x, which is sine x, is cos x, right? So for my v of x, which is minus 3 times sine x, will be minus 3 cos x, right? Now I have my, I'm going to go back to the original expression what we wrote, and let's call back our f dashed of x. My f dashed of x, which was u dashed, which we calculated, it's a very simple one, which is 1. And then I have my v dashed. So my g of x is sine x, right? And we calculated what is g dashed, which is cos x. So what is my v dashed? My v dashed is nothing but minus 3 into cos x, right? So which makes my expression as minus 3 cos x, right? And why is that? Because the d by dx of a constant k is always 0, right? So what happens is when you uh, apply d by dx of k times a function, say in this case g of x, so k into g of x, okay, let's assume that there's a function k into g of x. The d by dx of k into g of x is you pull out the k, and that becomes equal to k times g dashed of x. And I'm just going to write that for you so that you remember that